AI engineer, machine learning specialist, deep learning researcher, data scientist. Job postings use these terms interchangeably. News articles mix them up constantly. And I guarantee some of you watching right now aren't 100% sure what the difference is. Today, I'm going to give you a mental model so clear that you will never confuse these terms again. Let's fix this once and for all. Welcome back to the AI kingdom. Over the last two episodes, we defined AI and explored its three levels: ANI, AGI, and ASI. Now we are tackling one of the most common sources of confusion in tech: the relationship between artificial intelligence, machine learning, deep learning, and data science. Here's what I want you to understand by the end: they're not even the same type of thing. Once you see how they fit together, everything will click. Let me show you why this is so confusing. Google AI versus ML and you'll find 100 different diagrams. Some show ML inside AI, others show them overlapping. Some add data science inside, others outside. The problem is that people are comparing things that aren't directly comparable. It's like asking what's the difference between transportation, cars, and electric motors. Well, transportation is a need, cars are a solution, electric motors are a component. Similarly, AI is a goal, ML is a method, DL is a subset of that method, data science is a discipline. Let me explain each properly. Start with artificial intelligence, and I'm going to tell you something crucial. AI is not a technique, AI is a goal. This is the most important point I'll make today. AI is the goal of creating systems that perceive, reason, plan, learn, and act toward objectives. Let me give you the formal definition. AI is the science and engineering of building systems that perceive, reason, plan, learn, and act towards a goal. Notice this says nothing about how to achieve it. You could theoretically build AI with explicit rules like if and then statements, statistical learning, evaluationary algorithms, symbolic reasonings, or something we haven't invented yet. The goal is intelligent behavior. The method is whatever works. In 1950s through 1980s, AI was mostly about expert systems. If patient has fever and cough, consider flu. That was AI, no machine learning needed. Today, the most successful approach to achieving AI is through machine learning. But ML is not the only way to do AI, it's just currently the best way. Now, let's talk about machine learning. Here's the definition: machine learning is a subset of AI that enables systems to learn patterns from data rather than being explicitly programmed. This is a fundamental shift in how we build intelligent systems. Traditionally, human writes rules, computer follows the rules. In machine learning, human provides data, computer learns rules. Let me make this concrete. Imagine building a spam filter. Traditional approach, you'd write rules like if mail contains Nigerian prince, it's a spam. If mail has more than three links, maybe spam. If sender is not in context, suspicious. This works, but until spammers change their tactics, then you need to write more rules forever. ML approach of building this: you give the system thousands of emails labeled spam or not spam. The algorithm finds its own patterns, the patterns you might never have noticed, and when spam evolves, you just retrain with new data. Machine learning brought three crucial capabilities to AI. One, reduced manual rule writing. Instead of encoding every possible case, we let algorithms discover patterns. Two, statistical generalization. ML models can handle cases they have never seen before, as long as they are similar to the training data. 3. Scalability. Rules don't scale, data does. More data usually means better ML. But here's the limitation: traditional ML is still task specific. A spam classifier can't suddenly do image recognition. It learned one task. Now we get to deep learning, and this is where things get exciting. Deep learning is a subset of ML that uses multi-layer neural networks to learn representations automatically. The key phrase is learn representations automatically. Let me explain why this matters. In traditional ML, humans still had to do feature engineering. This means deciding what inputs matter. For example, in image recognition tasks, humans had to manually design features such as edge detection, color histograms, texture patterns, then feed those features to the ML algorithm. Deep learning changed everything. Deep neural networks learn features themselves. You give them raw pixels and they figure out, for example, in layer edges and gradients, for example, in layer 2, shapes and textures, in layer 3, parts like eyes, nose, wheels, maybe in layer 4, whole objects like faces, cars, or something like that. This is called representation learning. The network builds its own hierarchy of features. What deep learning brought to AI was 1. Representation learning. No more manual feature engineering. 2. End to end learning. Raw input, final output, the network figures out everything in between. 3. Massive breakthroughs in computer vision, image recognition tasks, object detection tasks, speech recognition like Siri, Alexa, and transcription, natural language like GPT, ChatGPT, Claude, BERT, multimodal AI, systems that combine visual, language, and audio. Deep learning is why AI exploded in the 2010s. The techniques existed for decades, but three things finally came together: massive datasets, GPU computing power, and algorithmic improvements. Now, is all machine learning deep learning? No. You can do ML with decision trees, random forests, support vector machines, linear regression, k-means clustering. None of these require neural networks. Deep learning is one way to do ML, currently the most powerful for complex patterns. Now, let's talk about the fourth term, data science. This one is different from the others. Data science is an end to end discipline focused on extracting insights, knowledge, and decisions from data. Here's the key distinction: data science is a discipline, a field of work, not a technique. It's problem driven, not model driven. A data scientist's job includes 1. Data collection, getting the data you need; 2. Cleaning and pre-processing, fixing messy, incomplete data; 3. Exploratory data analysis, understanding what's in the data; 4. Statistical analysis, finding patterns, testing hypotheses; 5th, modeling, sometimes using ML, sometimes not; 6th, visualization, making results understandable; 7th, storytelling, communicating to the stakeholders; 8th, business decisions, driving actual outcomes. Notice something important? ML is just one tool a data scientist might use. Many data science projects don't involve ML at all. Example: a data scientist at a retail company might analyze sales data to find seasonal patterns, no ML required. Create dashboards for executives, no ML required. Use A/B testing to compare website designs, statistics, not ML. Build a demand forecasting model, this uses ML. Data science may use ML or DL, but it doesn't require them. A pure statistics analysis is still data science. So, how does data science relate to AI? Data science is one way to apply data, statistics, and models to drive intelligence and decisions. It overlaps with AI when ML and DL is involved, but it's a broader discipline with its own scope and methods. Alright, let's put this all together with a visual framework you can remember forever. Picture a Russian nesting dolls or nested circles. AI is the outermost layer, the biggest circle. It represents the goal, machines that exhibit intelligent behavior. ML sits inside AI, a smaller circle. It's one method for achieving AI, learning from data instead of explicit rules. DL sits inside ML, An even smaller circle, it's a subset of ML using neural networks to learn representations automatically. Data science is a separate circle that overlaps with AI. It's a discipline that sometimes uses AI, ML, DL tools, but has its own distinct methods and goals. Now, let me give you the one liner summary. AI is a goal which aims to build machines that exhibit intelligent behavior. ML is a method, it's a system that learns from data instead of rules. DL, subset of ML, learning via multi-layer neural networks. DS, a discipline extracting value from data. Or even simpler, AI is the umbrella. ML is one way to achieve AI. DL is one way to do ML. And DS is one way to apply data, statistics, and models to drive intelligence and decisions. Let's cement this with real world examples. I'll describe a system and we'll classify it. 1. Netflix recommendation engine. Is it AI? Yes, it's exhibiting intelligent behavior, suggesting content. Is it ML? Yes, it learns patterns from viewing data. Is it DL? Probably. Modern recommenders use deep neural networks. Is it data science? The people who build and analyze it are data scientists. Siri or Alexa voice assistant. Is it AI? Yes. Perceives speech, reasons about requests, takes actions. Is it ML? Yes. Learn from millions of voice samples. Is it DL? Yes. Uses deep neural networks for speech recognition. Is it data science? Data scientists work on improving accuracy and analyzing errors. A/B testing on a website. Is it AI? Not really. No intelligent agent behavior. Is it ML? No. It's statistical comparison. Is it DL? No. Is it data science? Yes. Extracting insights to drive decision. Excel spreadsheet analysis. Is it AI? No. Is it ML? No. Is it DL? No. Is it data science? Yes. Data science includes basic analysis too. In 1980s, expert system like Mycin. Is it AI? Yes. Intelligent behavior for medical diagnosis. Is it ML? No. It used hand-coded rules. Is it DL? No. Is it data science? No. Pure rule-based system. See how they are related but distinct? You can have AI without ML, like rule-based systems. ML without DL, like random forest, linear models. Data science without any AI, like descriptive statistics, visualization, or all of them together, modern recommendation system. Before we wrap up, let me address common mistakes. Mistake 1. AI and ML are the same thing. No, ML is one approach to AI. You can have AI without ML. Mistake 2. Deep learning is just a marketing term. No, it specifically means multi-layer neural networks with representation learning. It's a real technical distinction. Mistake 3. Data scientists just do ML. No, ML is maybe 20% of what most data scientists do. The rest is cleaning data, analysis, communication, and business strategy. Mistake 4. You need deep learning for everything. No, simple problems often work better with traditional ML. DL needs a lot of data and compute. Sometimes linear regression is the right answer. And now you'll never be confused between AI, ML, DL, and data science again. Remember, AI is the goal, ML is the method, DL is a powerful subset of ML, DS is the discipline. They are related, but they are not the same thing. In our next episode, we are diving into one of the most important distinctions in the modern AI: models versus agents. Understanding this difference is crucial for understanding how ChatGPT and Claude actually work. Subscribe and hit that bell to catch it. I'm your guide at the AI Kingdom. See you all in the next one. Thank you.